Hello everyone, welcome back to the Azure Functions series. Here we are talking about serverless computing. We all know that it's powerful, but what happens when you need to manage state, coordinate long-running workflows, or wait for external inputs? That's where Azure Durable Functions come in. Today we'll explore how it works and review a couple of common patterns to build robust, durable functions. Let's get started. The first thing we should understand is what durable functions are, why they exist, and when to use them. So, what are these mysterious functions? Durable functions are an extension of Azure Functions that enable stateful, long-running workflows in a serverless environment. Unlike standard Azure Functions, durable functions manage state and execution history for you. Answering the question of why they are useful, there are a couple of key benefits. They handle complex workflows without requiring you to manage databases or external storage. They enable long-running tasks while remaining cost-efficient, and also they orchestrate multiple functions while maintaining state. As for when to use this tool, it's suitable for a wide variety of situations, such as when you need serverless workflows that maintain state, when you have sequential or parallel functions execution, and when you need to wait for external input before continuing. Now that we know why durable functions are useful, let's explore their key components. Durable functions have a few key building blocks that make them powerful. Let's go through them one by one. The first one is the starter function. It initiates the workflow of a durable function and is often triggered by an HTTP request, a queue message, or a timer. Imagine submitting an order on a website, which then triggers the order processing workflow. This sends a message to our second building block, the orchestrator function, which is the heart of this logic. It controls the workflow, determines the execution order, calls the orchestration logic, and manages state. And last but not least, we have an activity function, which performs the actual work, such as calling an API, processing data, or sending an email. These tasks can all be handled by different Azure functions. The orchestrator decides how and in what order your activities will run. Now, let's put this into action with real code. The first thing we should do in VS Code to be able to operate with durable functions is install a new PyPy package called Azure Functions Durable and add it to our requirements. When it's done, it's time to create our first durable function setup. First, we update the app's base class from the default Azure function to durable function. We import Azure Durable Functions as DF and use DF app as an instance of Durable Functions app. Once the app is set up, it's time to configure our main function here. We start with the orchestrator function, which requires the orchestration trigger decorator to wrap around a Python function. This decorator takes a context name argument, instructing Azure to pass the orchestration context as a parameter named context. This context provides methods for calling activity functions, managing state, and controlling execution flow. The next step then is determining how to orchestrate activity functions effectively. Fortunately, it's straightforward. Simply use yield context call activity and pass the necessary arguments, the first being the name of the function to call, process payment, and the second being its input, order ID in this example. Next, let's define the order ID variable. It should be retrieved from the input passed by the starter function, which we can do using order ID equals context get input. As for this yield statement, it's required because Azure Durable Functions follow an asynchronous workflow execution model. But where is this activity function defined? It can be either another Azure function with the same function app, or simply a function named process payment, wrapped with the activity trigger decorator This decorator requires an input name argument, which is mandatory and will be passed to the actual function. With this setup, we already achieved a lot. We have our first activity function defined and an orchestrator function that calls it. However, there's still one crucial piece missing in our durable function setup, the starter function. Let's create it now. Start by defining a new async function that will serve as an HTTP-triggered starter, then wrap it with two decorators, root and durable client input, both from the apps base class, root. This makes the function as HTTP trigger that listens for the post request. However, we do not define an explicit root, which means the framework automatically assigns the function name HTTP start as the root. It also gives us a request object as an argument to our function. There are more possible arguments to pass in, which we can check in the source code, but we don't need all of them yet. And durable client input. This injects a durable orchestration client instance, client argument, into the function. This client allows the function to start a durable orchestration. In the body of this function, the first step is to retrieve the order ID when the trigger is activated. This happens when the order is received and requires processing. We extract the order ID from the request parameters. Next, we initiate the orchestrator function workflow by calling client start new function, passing the orchestration function name order processing orchestration and the order ID as the client input. This call returns a unique instance ID for tracking the orchestration. Finally, the function should return an HTTP response containing URLs to track the orchestration status. This is done by calling client create check status response, passing the request and the orchestration instance ID as arguments. Now that our setup is in place, let's add some functionality and run our durable function. We already have a payment action. We just need to add a print statement and return true, assuming the payment always succeeds. But charging for an order alone isn't enough. Let's add an activity function to check if an item is in stock. This function will simply print that it's running and return true. The final step is the shipping activity function, which follows the same pattern as the others. Now we can integrate these functions into the orchestration logic. First, we will check if the item is in stock. If not, return out of stock. Then process the payment. If it fails, return payment failed. And finally, ship the order. If payment succeeds, call ship order and return a success message, order shipped. With these steps in place, our durable function is ready to run. Durable functions require an Azure storage account to run, so ensure it's set up. In this case, we will emulate it using local storage by adding the following settings to the local settings JSON. Azure Web Jobs Storage should be use development storage set to true. Then we run a Docker container to emulate the storage connection. Check the command in the description for details. And one more important note for Azure Functions in Python. Ensure that your activity trigger input name does not contain underscores. Use camel case for variable names to prevent errors. Now let's start the debugger and see it in action. We have a URL to trigger our starter function, which we can call from the terminal using this command. From the response, copy the value under the key status query get URI and paste it into your browser. Now we can debug the function in VS Code and monitor its status directly from this URL in the browser. And that's a wrap for the first episode of Durable Functions. We will catch up on the common patterns to build durable Azure functions in a second video. Thanks for watching, see you there soon!